Okay, good afternoon, class. So at this point we are looking at the grade 10 paper. Sorry for the delayed start, as you know it was load shedding. Right, so the question says, use your calculator. At this point you guys have worked through these questions already. Eh? This is use your calculator to solve for x if x is less than 90 degrees. That's where we must start, no? Is that correct? So what we do is, we use arctan on both sides. So x is equal to arctan of 0,3. On the calculator you press shift, then we are 0.3. Shift. 16,7 degrees. Is that correct?
Yes, yes.
So 16,7 degrees. Okay, let's look at the next question. Okay, 4.2.2. So what do we have to do first? Divided by 3 both sides. So tan of x minus 10 is equal to 2/3. The paper and the memo can be found in the description box below. Okay. People, we can't take this 10 over the equal sign. Not so.
Yes.
We must first take arctan. Okay. Oh, sorry, arc sign to get this angle on its own. So we say x minus 10 is equal to arc sign of 2/3. Okay, so in the calculator, we shift sign or arc sign of 2/3 is 41,81. Let's take 10 over. I would of course add the 10, not so. So it's going to be plus 10, 51,81. Okay, any confusion there? No? Let's go to the next question. A bit longer. 4.2.3. So here, of course, we know we can put this in a calculator, not so. So sine squared 40 plus cos squared 40 gives you an answer of 1, not so. Is that correct?
Yes. Yes.
Sine 40 squared plus cos 40 squared. Now for those of you, we spoke about this when we did our chapter of this, okay? We know that sine squared theta plus cos squared theta is 1. Did I mention that before? Okay. So if you forgot it, no problem. You can work it out, gives you an answer of 1. So 1 is equal to 1/3 sec x. So to get a third on its own, sec x on its own, I divide by a third. So that cancels. So sec x is equal to 3. But now, do we have an arc sec button on a calculator? No. So sec is the inverse of? So in other words, is 1 over sine x is equal to 3 over 1. Not so. So what I can do is I can flip. I can take the reciprocal both sides, so I can cross multiply. So 1. But cos. Sorry about that. It's cos. So I can take take the reciprocal here, which is cos over 1 is equal to 1 over 3. Or if you didn't know that, you can cross multiply, so 1 is equal to 3 cos of x. So cos of x is a third. So what do I do now? Now I say arc cos of a third. Okay. And of course arc cos of a third is 70,53. Is that correct?
Yes.
70,53 degrees. Did I tell you to one decimal place or what?
No.
No. Okay. Any questions? Any confusion there? No? Next. In 4.3 we are told simplify the following without using a calculator. So what do I always encourage you guys to do here in this case? Draw your triangles. The diagrams needed. Of course, the special triangles are as follows. There's going to be 30, 60, 1, 2, root 3. And then, of course, your isosceles triangle, which is 45, 1, 1, root 2. And, of course, this which is not a triangle, but it works what we're looking at. So there's no, what's the name there? 1, 1. Okay, so sine 45. So sine is opposite over? Opposite over? Hypotenuse. So it's 1 over root 2 times tan 20. And tan 20 cancels, not so? Sine 45. Sine of 45 is sine's opposite. Cos, I don't have my glasses on, my eyes is itching. Sorry about that. So it's adjacent over hypotenuse is 1 over root 2. Not so? Over tan of 60. Tan is opposite over adjacent. So it's root 3 over 1 times tan of 30. Opposite over hypotenuse. The opposite of adjacent is 1 over root 3 minus cos of 90. Cos is? So it's going to be 0 over 1. Okay, so what happens now? Root 3 cancels root 3. So the denominator is the 1 here. Not so? So what is 1 multiplied by 1? 1. Root 2 times root 2? 2 minus 0, which is? Oh. Okay. Without the use of a calculator. How do you know you're going to be using calculators? We look at things like this here. Okay. And as I explained to you before, or encouraged you guys before, if you are given this question, write down your triangles on the side as well. Okay. Okay. Let's carry on. Now we're looking at question 5. Question 5, we are told without using a calculator determine AC in third form. Okay. Now you're going to calculate AC by using Pythagoras. So AC squared is equal to 7 squared plus 9 squared. Do I need a reason here? No. When do I need a reason for Pythagoras? Geometry, Euclidean geometry. So of course that's 49. This is 81. Or also when they ask you to give a reason. Okay. It's going to give you 130, not so?
Yes, sir.
So to get AC on its own, I square root both sides. So AC works out to the square root of 130. Then he says cos of theta. People, here's theta. Cos is adjacent of hypotenuse. So cos of theta is going to be 9 over the square root of 130. Okay, any confusion there? No? So here we are told that in the diagram below, ACB is 90 degrees, ADC is 90 degrees, ABC is 155, AB is 15, and AD is 4.4. Determine X. Now you see X lies in two triangles, not so? Is that what there? But we show it in the Y in pursuit of calculating X. We have no angles there. However, in this triangle here, we don't have BC, but we've got the angle. So this is what to the angle? Your opposite. And this is your hypotenuse. So which trigonometric function is we can use here? You're going to use sine, of course. So we say sine of 55 is equal to opposite, which is x over hypotenuse, which is 15. So what do I do now? Cross multiply. So x equal to 15 sine 55. Then the calculator says 15 sine 55. 12.29. 12.29. centimeters. As you can see, the centimeters there. So what I do is I put this on the diagram. Okay. Look at the next question. The next question says calculate the size of ACD. The size of ACD. So we've got A, C, D. This angle here. Not so. Okay. So which thing now what do we have here? We have an opposite and the hypotenuse of that triangle. Not so. So which trigonometric function uses opposite and hypotenuse? Sine. So you say sine ACD equals opposite, which is 4.4 over 12,29. So how do I get that angle on its own? ACD is equal to arc sine of 4.4 over 12.29. So let's go, we go shift sine. Arc sine of 4.4 over 12.29. 20,7 8. 20,98. You all agree with that? Okay, last question is then to solve for y. How you can solve for y? You can do it. You can either use this is what's this to us? Adjacent and hypotenuse, which is cos. Or I can use opposite and adjacent, which is tan. Or Pythagoras. I'm going to use Pythagoras here. Okay. So for number 3, it is of course going to be 12,29 squared is equal to y squared plus 4.4 squared. Again, the reason is not required. So y squared is equal to 12.29 squared minus 4.4 squared. Okay. Otherwise, you could have gone straight into that, and also you establish that you are working one of the sides up to the hypotenuse, and you go straight into the minus. There's no problem with that as well. So 12,29 squared minus 4.4 squared. 131,68, the square root thereof gives you 11,4. Okay. Any confusion there? Any questions? No. Right. Let's go to the next question. Okay, question 6. We are moving too fast. Okay, here we are given that 37 sine theta is equal to 35, where theta is greater than 90. What does greater than 90 mean? It's an obtuse angle, yes? Represent the information in the diagram in the correct quadrant. Calculate the size. Calculate the size of the unknown length as well. Unknown length. Okay. So firstly, we're going to divide by 37 both sides to get sine of theta on its own. So it's going to be 35 over 37. Okay, so it tells us it's greater than 90. So if we draw this diagram, we know that's 0, 90, 180, 270 and 360. If something is greater than 90, it can be in one of these quadrants. Okay, but because sine is positive, and sine is positive in quadrant 1 and quadrant 2. Okay. So we need to draw in quadrant 2. Okay, or you consider sine to be obtuse is anyway in quadrant 2. Okay. So what we do is conclude the triangle. Remember, if the arm is in the first quadrant, we always drop it perpendicular to the x. Okay? Even if it's close to the y, it will still come down to the x. Okay? It's in that quadrant, perpendicular to the x. Third quadrant, perpendicular to the x. Fourth quadrant, perpendicular to the x. We always drop it perpendicular to the x. Okay. Zoe? Michael, what you busy with? I'm a what? On the page. You didn't do the homework. So while you're on the page, you must be marking your work. What does sine stand for? Opposite over? Hypotenuse. So there's my theta angle there. Okay? So your opposite is of course 35. Your hypotenuse is 37. How do I calculate this adjacent side? How do you calculate this adjacent side? Pythagoras. So we now say of course 37 squared is equal minus 35 squared, and this is for your adjacent side squared. Alright, so you put it in the calculator. 37 squared minus 35 squared. 144, the square root of that is 12. Okay, but if I introduce square root, must I not forget? Plus minus. So which one of the two is this one here? It has to be the minus. Why? So it's in the negative part of your y-axis. Or x-axis. So why didn't we go, when we apply Pythagoras here? Because this is length here. And your length is never negative. Can you see that? Okay, so let's just answer this question before we break for the end of the lesson. Before we break. So it's 6.2. We asked, hence, without the use of a calculator, determine the value of 12 tan theta plus 35. Okay? So that would simply be 12 tan. What is tan of theta? Opposite over? Adjacent. So it's 35 over negative 12 plus 35. That of course cancels, not so? So positive divided by negative? Negative. So negative 35 plus 35, which is? 0. And then the last one here. Using a calculator, calculate the value of theta. So now we're using a calculator. Okay. So when you work this out, there's your theta angle. So we say sine of theta is equal to 35 over 37. Or I could have said cos of theta is adjacent of hypotenuse. Or I could have said tan of theta is opposite of adjacent, whichever one. So what I do is I take arc sine of 35 over 7. So if we shift arc sine of 35 over 37, you 71,07. Okay. But if you look at 70, is this an obtuse angle? Yes. So that angle of 71,07 is that angle there. Can you see that? So how do I get this angle here? The angles on a straight line, which is 180 minus 71,07. This gives us an angle of 108,92. Right, you guys understand? Okay, in our next lesson we'll wrap up this paper, hopefully. We just have geometry. Oh, graphs. And then geometry. Measurement as well. We'll hopefully finish in the next lesson. Okay, good morning class.